Again, in this problem, we want to convert Cartesian equations into polar form by hand, but these aren't going to be quite as easy as the last ones we've done. So just remember that x is equal to r cosine theta, y is equal to r sine theta. Okay, so if that's the case, then for y, I can type r sine theta equals 3 r cosine theta plus 2. Now remember, when I want to get something into polar form, what I want is for it to be r is equal to some function of theta. So I want all the r's on one side and all the thetas on the other. Well, let's see here. Let's start by getting the two of them together. So r sine theta equals 3r cosine theta plus 2. That means r sine theta minus 3r cosine theta equals 2. Why did I put them together? Well, because then I can factor r out. Like that. How does that help me? Well, remember, I'm trying to get r by itself here. So if I do that, I'll have r equals 2 divided by sine of theta minus 3 cosine of theta. Now, we already know what this graph looks like. We knew it when we looked at it. It's a diagonal line, right? It's a diagonal line of slope 3 with a y-intercept of 2, right? So we can graph it. It'll look like this. So a simple diagonal line in Cartesian coordinate system is a kind of interesting function in polar coordinates. Let's double check how it graphs. So let me grab Desmos. And then here it is. So there's the 3x plus 2, that's Cartesian. And there's the polar graph. 2 divided by sine of minus 3 cosine theta. And sure enough, it works out. Diagonal line. So very simple equation in Cartesian coordinates, but not so simple in polar coordinates. All right. Now what about y squared equals 3 minus x squared? Okay, so y squared would be r sine of theta squared equals 3 minus r cosine of theta squared. All right, so that's r squared sine squared of theta equals 3 minus r squared cosine squared of theta. Remember, you're trying to get r by itself. So I need to add this r squared over here. So r squared sine squared of theta plus r squared cosine squared of theta is equal to 3. And hopefully you're thinking what I'm thinking. Sine squared plus cosine squared is 1, right? If I factored the r squared out, I'd be left with sine squared of theta plus cosine squared of theta, which is 1. So that means that r squared is equal to 3, which means r is equal to plus or minus the square root of 3. Remember, whenever you take the square root of both sides, it technically could be positive or negative. Okay, but that's a circle. Like, that's a circle because r is equal to a constant is always a circle. It's a circle. It has a radius equal to the square root of 3. It has a center at the origin. And I know what you're thinking. Is that xy or is it r theta? And the answer is it doesn't matter because it's still the origin. So you could say it's x comma y, or you could say it's r comma theta. Either way, it's still the origin, it's still the pole. And if you don't believe, let me grab Desmos. All right, so there's the lovely rectangular graph, the Cartesian graph. And then if I click the polar graph, there it is. It's like an orange color, right? And it doesn't matter if you do negative square root of 3, positive square root of 3. It doesn't make any difference. It matters not, because one's heading out in the positive polar axis, one's heading out in the negative polar axis, but it's still going to draw the circle. So it doesn't make any difference.